All right. 2i squared. You square the 2, what do you get?
4.
4. You square I, what do you get?
-1.
Negative 1. What's 1 minus 4 times negative 1?
5.
5. So if we were doing a unit on just on complex rectangular, I would expect you to FOIL this out as well. And then we'll talk about that in actually a little bit more in the spring, what you would do from here. But this is how you do division with rectangular complex numbers. Yes?
Is it ever faster to switch to polar, like, instead of doing rectangular multiplication at all, would it be easier to switch to polar?
If you have a calculator, I often would, yeah. It often is. And I always say with the calculator part because you're rarely going to get handed. Well, it depends. That's a great question for a test, actually, where, like, if I give you the numbers, like if I give you two sets of rectangular numbers to multiply, and you see that they have a lot of square roots of 3s or square roots of 2s in them, then that's my hint of saying, turn this to polar and it'll be easier. Okay? So, polar division now.
Are we going to do subtraction too?
No, I said subtraction was just like addition. You don't do, we're not going to go over that. Polar division. Give you an example. If I have R, what was my example from last time?
For what? Division or?
For multiplication.
Or
That? Oh.
Yeah, what were the two numbers I gave? Something cosine, something cis, what was it?
It's
3 cis 45
2
times
cis
2 cis 30.
3 cis 45. Here's a notation your book will use sometimes. They'll say z sub 1 is 3 cis 45, for example, and z sub 2, what did I say, 5 cis 30?
Yes.
No, 2 cis 30. 2 cis 30. So they'll label them, call each polar imaginary number z, and use a different subscript. If I'm asking you to divide these two, I might say then what's z1 over z2? And what you do is you divide the numbers, subtract the angles now. It's the inverse of what you did for multiplication. What's 3 divided by 2?
3 over
3
2.
halves.
3 halves, 1.5, a couple different ways to write that. What is 45 minus 30?
15.
15. Which is easier, rectangular complex division or polar complex division?
Polar.
Polar. So yeah, depending on what numbers you're given and whether or not you have a calculator, Ramsey, I could see a lot of cases where it'd be easier to not do that, convert them to polar, and just do this instead. You get the same answer.
Wait a second, so polar is easier for everything?
Not addition and subtraction. I didn't give you an addition and subtraction method because it's ungodly. It's like adding vectors on steroids. It's basically you find the components anyway. So it's just like, remember adding vectors in physics, we had to find the components anyway to do it? So it's the same idea. You really have to use rectangular for addition and subtraction. But for multiplication and division, you really want to use polar. And I'm going to take that a step further now. Any questions on division?
Kind of. Are we going to have, like, work time today?
Possibly. I'm hoping so.
I really could not.
Okay. It's up to you. You can go now or wait. Take your pick.
There's a
Walk around
video.
the back. Don't care. Okay. Next thing.
Pee in a bottle.
Okay. Exponents.
You're supposed to walk around the back.
It's all right. It's fine. Don't worry about it. Don't worry about it. Just go.
Her name's
Exponents.
Don't say names.
Stop. Exponents. Exponents, exponents. Okay. Who here... I'll do one that's fair. I'll actually do the same one twice. Do one that I think I can convert. Who here thinks it would be fun to do
Nothing.
5 root 3 over 2 plus 5 halves I to the 6th power by writing this out 6 times and foiling it
Oh my god.
and repeatedly distributing? Parker, I'll give you extra credit if you do it.
Wait, is this
Right now?
rectangular
Wait,
or
right now?
polar?
This is rectangular. Thank you.
Right now?
No. This is rectangular.
I'll do that.
Okay? I'm not even going to work this out. I'm not even going to bother to work this out. I don't even care what this would work out to. But now, Who can convert this quickly for me into polar form?
That's a 45-degree angle.
No, it's over 3 over 2 and a 1/2.
It's 30.
It's 30, that's correct. Sine of 1/2 is 30. What's my...
5 cis 30.
This is 5 cis 30 degrees.
Do you always convert it to polar when you're doing rectangular exponents?
Yes, I really do. When you're doing... yes, I don't want to see anyone even try to foil this on a test.
Unless it's squared.
Unless it's squared, then sure. Okay, now 5 cis 30, here's the rule.
What if someone did?
The rule is, okay, the rule is you raise the r, your absolute value, your length, to the power, and you multiply the exponent by the angle. So this equals 5 to the 6th power. I don't know that one off the top of my head.
15,625.
Okay, and it's cis 180.
So 6 times 30. So you multiply.
Multiply the exponent times the number. So you're multiplying the exponent times the angle, and you're raising the length to the power. 5 to the 6th, cis 180. Just out of curiosity, is this number... Go ahead.
Multiply your degrees.
Yep. Multiply the degrees by the exponent.
What happens if you're not allowed to distribute exponents?
Oh my god.
This isn't really it doesn't really count as distribution when you're doing one operation here and a different operation here. You know, I'm raising to a
But
power
your
here.
exponent is still going inside your parentheses.
Yes, it is.
That was a big no-no.
In a new and strange way. It is a big way if there's addition or subtraction. But remember, Megan, it's only a big no-no if there's addition or subtraction. If there's multiplication, you have to. And this is not any of the above. Yeah, this is whole new range. Order of operations is gone. Okay, so this. Yep, that's what you missed.
And you always convert to polar.
Yes, don't even try this.
I need that.
Just out of curiosity, quick thinking question. Okay, is this answer real or complex?
It's real complex.
It's
real.
It's real.
It's real complex. It's real.
It's real because the 180 degrees means it's just on the negative x-axis. So this actual answer is just negative 5 to the 6th power, whatever that number is. Cis 180, remember, is just along the negative x-axis. It's a little extra thing if you can picture it. So this is the final answer in simplified form.
Which is negative 15,625.
Negative 15,625, correct. So I wouldn't expect you to know that. By the way, well, let me put it
That's
this way.
under negative 9,000.
It's true. This is a fair question without a calculator if I expect you to leave your answer in this form or this form. Okay, so if you get this without a calculator, don't panic. Just you're expected to leave it as 5 to the 6th. Is that clear? You guys all right with that?
That is a far way down the number line.
Yes, that is way, way, way to the left.
To the
Like
left,
Megan.
To the left. Ha.
Yes, that's right.
Oh.
Alright,
Oh.
Interesting side note here. Interesting side note. We started out by raising a complex number to a power, and the answer was real. Sometimes these things can move back and forth in interesting ways. You can move onto the real number line and off the real number line.
Even, it's real.
maybe with
If it's
imagination.
odd.
No, it's weirder than that. And I'm going to save that for tomorrow. Actually. We're going to talk more about exponents and roots. But you have, well, all you really need for tonight's homework is the multiplication and division, I believe. And tonight's homework is, let me double check this.
Parker, seriously.
All right. Tough, Johannes.
Am I
Is just-
am I allowed to show students?
Correct.
Oh, I'm showing you now, Parker.
Is 38 to 52 even on page 696? All right? Okay. Thank you, and you've got time to begin.
It only fell